Presentation is going to be in English, and so I'm professor of computer science at the University of Victoria, and my talk is mostly about the research that we have been doing in the last few years. Feel free to ask questions as I go if you have them, and rather than to wait to the end. So I'm happy to answer them when you have them. So I come from Victoria, which is in the west coast of Canada, so a little bit far from Porto Alegre. So I don't have to tell you, but we have free and open source software everywhere. And perhaps the best example of that is the use of mobile phones these days. And I want to talk a little bit about OpenSSL and Heartbleed, and because it's a very interesting case for the media. And I'm going to make reference to three publications that they are particularly important in the world. And so in The Economist, The Economist said, Heartbleed is a software flaw that has left up to 2/3 of the world's websites vulnerable to attack by hackers. What I really like about this quote is that in a mainstream article, it's already saying that 2/3 of the internet, of the web servers, are being actually using OpenSSL. And there is a famous, well, not so famous, but an Irish author who said that there's no such thing as bad publicity except for your own obituary. And I think that the case of OpenSSL is going to be very good for open source in the long term, even though for some might have been bad publicity. And so The Guardian says, most open source software, and OpenSSL is no exception, is produced voluntarily by people who are not paid for creating it. They do it for love, professional pride, and as a way of demonstrating technical virtuosity. And mostly they do it in their spare time. And he keeps on going by saying, responsible corporate use of open source software should therefore involve some measure of reciprocity. I find this particularly valuable. And because he's already saying, so it's being used by people to make money, so let's put something back into that. So either in the form of financial support or by encouraging its own software people to contribute to the project. The New York Times writes, much of the invisible backbone of websites from Google to Amazon to the FBI was built by volunteer programmers in what is known as the open source community. Volunteers connected over the internet work together to build free software, to maintain and improve it, and look for bugs. Ideally, they check one another's work in a peer review system similar to that found in science. I really like this quote because even though it comes from a journalist, it really embodies what we see as the main advantage of free and open source development. You probably are familiar with Linus Law by Eric Raymond from the Cathedral and the Bazaar. Given enough eyeballs, all bugs are shallow. He was interviewed by the New York Times article, the author of the article, and he said, in the case of Heartbleed, there just weren't enough eyeballs. And this has actually created a lot of trying to understand what happened around the Heartbleed bug. So the code was created by the grad student. It was probably a project for his thesis, and it was reviewed by the core developer on OpenSSL as a big contribution. And of course, it means that Henson didn't find that bug at the time, but that he accepted the contribution. And so it was included in OpenSSL in 2011, and it took 3 years to be discovered. Well, officially discovered. We will never really know who found it before, who used it, how much advantage they took of it, but it took 3 years to know that. And one thing that's particularly interesting is the fact that the budget for OpenSSL, which was essentially donations by individuals, was $2,000 in 2013. We're talking about a core application. One of the interesting things about OpenSSL is not only that it does cryptography, but it's accredited by some organizations as cryptographic software. And so that allows many organizations to use OpenSSL to provide cryptography that has to be certified. So that's one of the reasons why it's so important for many organizations. So we now have some people call the OpenSSL problem, and which is the fact that there are very many infrastructure projects that they're run by a small team of volunteers. Everybody knows Linux. Everybody knows LibreOffice. Everybody knows Firefox. But these infrastructure projects, they get forgotten because nobody sees what happens behind. I think that happens with many libraries in general in free and open source software. And those are the ones that are run by volunteers because nobody really cares for them except their own authors. So on April 24th of this year, the Linux Foundation announced the core infrastructure initiative to try to address this problem. So it has funding by a lot of companies. Each one of them is expected to provide $100,000 a year. And the idea is to provide funding for core projects. And via fellowships, the idea is that these developers will be able to actually have a full-time job pay via a fellowship to develop this software. And they will also provide infrastructure. And also the idea of supporting money to do reviews of the code. And this is particularly valuable because it will allow outsiders to verify that that software is valuable. And and why do I detour a little bit? Because one of the areas that we have been working on is code reviews. And at the end of the day, the bug was found via reviews of the code. And it could have been prevented also by doing better reviews in the past. But I don't blame the people at OpenSSL. So let me actually talk a little bit about what do we define as free and open source software development. And if you ask me what is free and open source software, I will tell you that it's software that is released under free and open source license. Without a license, a free and open source license, there is no open source development. And the license guarantees that the code is available to others. That means that you can download the source code, but also that you can actually create other works based on that. There might be some requirements by the license, but you are allowed to do that if you agree to the terms of the license. But in some cases, it also becomes a social contract for the people. That's why some people participate in copyleft projects, and some people participate in more in academic licenses like the Apache, where even commercial use can be done with the software. But most frequently, when people talk about FOSS development, they talk about self-organized teams developing software without a central authority. In reality, there is always somebody running the show. But there's always the ability that if you don't like what they're doing, you can actually take a fork of the project and create your own. So that's also true. And at the end of the day, nobody really forces anybody to contribute. People contribute whatever they want to do. They might have some guidelines in terms of what they want. Linux is a very good example where even if you want to submit your code, they might not take it because they might not be interested on it at all. And important is that code is open for review and for reuse, and anybody can participate. That doesn't mean that they will like what you do, but you can try it. So now, what makes free and open source software development possible? So I divided it into 4 different aspects. So one of them is you need the people. Without people, there's no software. We don't have programs that are good enough to write software applications yet. And we need the internet because the internet becomes the channel of communication. And then we require a common toolkit that people are able to use to build this software. And version control systems are a very fundamental part of this today. So let me go into the teams. So they come from all sectors. So we have professionals all the way to hobbyists. We have people who have PhDs in computer science, all the way to people that they are in high school. And we have novices, people in universities, people that they are working already full-time in the big software companies. But most important, they're highly motivated to contribute. One of the things that I believe is fundamental to free and open source software, and one of the most important outcomes of free and open source software is the common toolkit. Because to be able to collaborate, you need to have the tools, and you need to have tools that everybody can actually use and share. And that involves the programming languages, the editors, the libraries, the infrastructure, and the hosting infrastructure. And if you have a movement like free and open source software where people are volunteering their time, these tools need to be free. And I'm talking about free as in beer. Because if you ask somebody, let's say in Brazil, somebody to pay 200 reais just to buy an editor so they can contribute for free to a project, that would be very, very hard to achieve. And I argue that the FOSS Toolkit is perhaps the most, or the biggest influence that, that free and open source software has had in software development in general. And I'll tell you a little bit about my own story building software. So I finished university in 1988. At that time, Turbo Pascal and Turbo C were the most dominant programming languages, at least in Mexico, where I was finishing university. But you have to pay for them. A lot of people, particularly us as students, we will just get pirate copies of the software. But it will cost $100 to buy a copy of Turbo Pascal. And it was relatively cheap for Americans, but not for Mexicans. Today, you don't have to worry about that, because you go to the internet and you download your compilers. You download whatever you want to use. You want to use Brazilian-made Lua. You want to use Ruby. You want to use Python, Perl. You want to use GCC, Fortran. Almost any programming language is available today free of charge. And the same happens for editors. And most people today use free and open source software editors. The only exception, I think, is Sublime. Sublime is the only editor that I see people paying for, but it's also because it's free to use and they don't verify the license. You're supposed to pay for it, but you don't have to, which is actually an interesting competition with free and open source software in that respect. And here is actually one area where the Free Software Foundation has a fundamental impact on this, because when Richard Stallman wrote his manifesto, he essentially said, we want to build a free and open source software operating system. But how do you start building an operating system? Because to build the operating system, you need a compiler. But to build the compiler, you need an editor. But you need the compiler to be able to build the editor. So they got into this chicken and egg problem. And that's why Emacs was one of the very first products that came out of the Free Software Foundation and GCC. So they could start building more and more. And today we have the entire ecosystem of applications. And a lot of people talk about Linux, but there is a lot of code from many other parts, and the Free Software Foundation has been fundamental to that. So I think that the world owes a lot to Richard Stallman. For this vision. I think that he was seen as crazy by many when he started, and now 3 years later, then it really shows the value of his ideas. But let me go back in track. Let me go back to code reviews. So one of the things that people realize in important projects, and those important projects are the ones in which that they are at the infrastructure level that others depend upon, and was that they needed to ship good quality software, and the easiest way to do it was by doing code reviews. I also believe that this is because developers don't like testing. Testing is boring, and in fact, for example, we have a quote from Linus Torvalds that says that he doesn't do testing. He writes the code and sends it to somebody else. If the code comes back to him, accepted, then he incorporates it. And I remember also that my very first job was doing testing, and I hated it. And because it was repetitive, and it was not the joy of creating. And so instead, let's do code reviews. And code reviews have been proposed for a long time in academia. And the idea was proposed by Fagan, and that's what we call them, Fagan code inspections. You finish a release, or you're very close to finishing a release, and then you go into a room. And then you project the code, and you start to scroll it and say, yeah, it looks good. No, this looks like a bug, so let's fix it. Or let's actually annotate that this looks bad, and then we can fix it later. It's not very widely used, except for big organizations. For example, I worked for IBM for a while, and they did code inspections in the product that I was working on. But for most of the organizations, they seem too expensive, because it's boring to actually go into a room just to look at code, and also people don't have time because you're always behind a schedule. So that has always been a big challenge. And so in open source, Fagan inspections were just completely invisible. because they require participants to be inside a room. So instead, they came with the idea of doing review of the patch. So you don't review the entire system, you just review the new change. You essentially are assuming that the old code is good, and the one that comes in is the one that needs to be reviewed. Each one of both, Fagan and incremental code inspection, has advantages and disadvantages, but this was the way that free and open source software has been working. We have created a few papers on code reviews. I'll talk in particular about the one that is at the left, Contemporary Peer Review in Action. And there's a whole spectrum of code reviews. So on one side, you have the very formal Fagan style, and in the other side, you have the very minimalistic code reviews that they are done via email, like Apache has been doing. Apache HTTP server has been doing it for a long time. And then somewhere in the middle, you have some tool support. Garrett is one of the interesting products that has come out of this. Google said code reviews, incremental code reviews are very useful, but we don't have infrastructure, so let's create a website where those code reviews can actually happen. So Peter Rigby, my PhD student, he came with this view of open source code reviews. He says, early frequent reviews of small, independent, complete contributions, and this is very important, they have to be small, they have to be complete. That they are broadcast to a large group of stakeholders, but only reviewed by a small, self-selected expert, resulting in an efficient and effective peer review technique. What did he mean by efficient? That they will review very fast. In open source, they typically are done within 2 days of the mail being sent, and they're effective in the sense that they find bugs. But code reviews, at least in the way that free and open source does it, is not only beneficial in terms of finding bugs, it also allows people to learn about the code. When you have a discussion in a mailing list, other people become aware of the issues. People who are learning get experience by observing what people talk about in their code reviews. That paper also suggests 5 lessons from free and open source software can be used in commercial software. So one of them is to do asynchronous reviews. So rather than get together to do the reviews, just actually do it via asynchronous methods. Whether it's a website or whether it's email, then both benefit. Frequent reviews, so the earlier that you find a defect, we know that for a very long time, the earlier you find it, the less expensive it becomes. And so if you can actually do the reviews as the code is being created, then the better. Incremental reviews, so review the small incremental and complete patch, but don't allow the patches to be too big. I think that was one of the problems with OpenSSL, that the patch that came with the entire feature was just too big to effectively review in this way. Experienced reviewers, you need people who understand the system. If you don't have experts, then doing the review, then it starts to lose effectiveness. But as I said before, the non-experts benefit from this review too. And let them self-select what they want to review. So don't force them, because once you have people who are self-selecting, then they're more eager to do the work than if you force them to do that. But if nobody wants a piece of code to review, then you might have to actually tell them, you have to go and review this, because you want everything to be reviewed. So let me now switch a little bit and then go into code version control systems, and because I think that they are very interrelated. From the very beginning, version control systems have been a very important aspect of free and open source software. And before we had them, the Free Software Foundation, for example, used to ship tapes to anybody who wanted to contribute, a physical tape. You had to pay for the cost of the tape, but essentially there was no profit involved. And you're probably too young to know Usenet, but in Usenet you essentially just posted to this huge mail list in the world your tar file, and people will download it from there. That's the way that Linux was first published, for example. And then people will start to distribute patches on Usenet. And today, version control is the norm, whether you use centralized ones like CVS or Subversion, all the way to Git or Mercurial. And in fact, I tell my students that never work for a company that does not use version control. Because if they don't use version control, there's a management problem in that company. When I finished university, version control systems were very expensive. They were a luxury that most small software companies could not afford, and was a luxury that the students could not have. And I think that's a very, very important change. Today, when you do your assignments in university, when you're doing your code, even your home directories, you can version control them. And I think that's a great benefit. So free and open source software really democratized the notion of version control. So now anybody can actually use it. So version control, from my point of view, is the circulatory system of software development, because it's the one that brings code everywhere and that it needs to be. And then a contribution becomes a contribution. The patch is one or more commits, depending on the version control system and the policies that each one of the projects has. So the idea is that the patch should be reviewed, but unfortunately, most version control systems do not support reviewing of patches. It's kind of separated from them. Sometimes it's possible. For example, Gerrit allows you to do code reviews on top of Git. And that's actually, I think, a great advancement. Now, code reviews in open source have essentially two models. Commit then review. So you commit your changes, and then somebody reviews them. That's the way that Apache has been doing it for a long time, Apache web server. And if you have commit privileges, you commit, and then people have the ability to vote on your commit. And if two people vote it down, then it gets removed. But the idea is that you don't want to slow down the developers. They know what they're doing, but you have some verification that they don't do something wrong. On the other hand, you have review then commit, which is more of the Linux system method, which is you review the patch before it gets in. And the idea is that you want to catch the errors before they propagate into other people. I suspect that this also has to do with testing. The Linux kernel is very difficult to test. It's very difficult to run a debugger, or impossible to run a normal debugger underneath the kernel. And so that's actually probably the reason that they prefer to do the review before, because it's very, very expensive to find a bug once it's in. So let me go a little bit into Linux. And so Linux has incorporated review, then commit for a very long time. And Linus Torvalds really needed integration between both the version control system and the review process. But no version control system in free and open source software did it. So he turned to a commercial product called Bitkeeper, and that did it. And Bitkeeper and Linux started this symbiotic relationship where Bitkeeper started to improve by satisfying the needs of Linux and the entire Linux community, and at the same time, Linux benefited. There is a lot of evidence that Bitkeeper improved the performance of the team. It was obvious that it was a good solution for them. But it was a commercial product, and the license said that the author of Bitkeeper, the owner of the company behind Bitkeeper, said you can use it as long as you don't create any competing products. And then one of them, the author of Samba, actually, he started to build a tool to download history. And that annoyed Bitkeeper, and they removed the license. So Linus Torvalds decided that it was a time to step a little bit out of the Linux kernel for probably a week, and then he wrote Git, which is kind of surprising, because, well, not surprising, but it's amazing because he's already famous for writing Linux, and now he goes and writes Git. And many of us will be happy to just have a little tool that people use. He now has two major applications in the software development ecosystem, not only actually open source, but in general. And so he goes and writes Git. So there are many other distributed version control systems, and many of them before Git. But in my opinion, what really made Git special was the view of pull requests. And I'll talk a little bit more about that in a second. And even though the code review is not involved within it, it's really thought in terms of being able to review the code before you incorporate it. And it can be done even via email. That was another very interesting feature that Git has, and that came from Bitkeeper. You can email the patches with all the metadata, and the recipient can actually incorporate them. So there are a lot of promises. So if you talk to anybody who has moved from any other version control to Git, they will tell you a lot of different reasons. You have easy branching, you have local commits, all the histories with you, et cetera, et cetera, et cetera. And now, one interesting problem with distributed version control systems is that instead of having one place, like with Subversion, now you have multiple places where the code is distributed. You never really know what is all the code that is actually being developed in the Linux kernel, because you will have to go to every single repository that has ever been cloned and ask each one of them, what do you have, what do you have, what do you have, to be able to know that. Because in Linux Torvalds, we only have what Linux Torvalds has accepted. But there's a lot of code that is being developed at the same time. I'll talk a little bit about it in a second. So there is one repository in the center that we call Blessed. That's the one where you go and download the official copy, so to speak. So in Linux Torvalds repository will be blessed for the Linux kernel. So how do you move the commits? Well, you have the push, in which I want to move my changes from my computer to another, so I push them there. But I need to have write access in the recipient. The other one is the pull, in which I tell the people, I have changes ready, please get them, and then they will actually copy them. Or finally, email. So it's very, very flexible in that sense. And one of the great advantages of distributed version control systems like this is that anybody can participate. You don't need authorization to have version control of your features. If you want to participate in a project that uses Subversion, then you cannot use their repository version control features. You are basically outside that. With Git, the moment that you clone, you can start to use version control as part of your development. So in any project that uses Git, you have this ecosystem of repositories, and which can be very, very small, just one repository where everybody commits as if it was centralized, or you can have this huge ecosystem. And let me talk a little bit about the life of a patch in Linux. So you go and make a clone of the repository of Linux Torvalds, write your patch, and create a patch and send that patch via email. And in the mail list, it will get reviewed. And if they don't like it, they will say, no, it's bad for this and this, and you rework it and get it. And finally, it gets approved and then put into a repository of a maintainer. And then it starts to move slowly all the way to Linux Torvalds repository. So there's like in transit time where you don't know where it is, but it's slowly moving towards Linux Torvalds. And finally, it runs in Linux Torvalds, and a few weeks later, he releases that feature. Sorry, that version of the kernel. So how do we find out how Linux uses Git? Well, the main problem that we have is because it has no centralized logging, we don't know all these commits that are happening and how they're moving. So how do we address this? We created a system in our university that every 3 hours, today goes around 650 repositories, and ask them, what commits do you have? What commits do you have? So the idea is that we discover when the commits are first available, and then we start to see how they start to propagate every 3 hours until they reach Linux Torvalds, and how from Linux Torvalds they start to propagate to all the community again. And so that was our original motivation. So that's been running since 2011. Let me give you an idea of the difference in data that we observe. So if we look at the column of Linux Torvalds, which I call snapshot, so if I go there and I make a log of that and look at 2012, I observe only 64,000 commits. In the continuous mining that we have been doing, we observe 479 repositories that contributed at least one commit to Linux in 2012. And the total number of commits was 533,000. So we're observing 9 times more commits in the super repository than in Linux Torvalds. So far more activity. Now, some of that activity is not true because what happens, people rebase. Rebasing is essentially changing the commit ID of a patch. So the patch might be the same, and it just gets into a new envelope. So it looks like it's a new one, but it's still the old one. So we accounted for that, and that's what we call unique non-merges. So in Linux, there were 58,000. In the super repository, there were 135,000. So there's twice more. And one of the reasons is that we are starting to observe the distributions. For example, Android. Android has a lot of commits that will never make it back to Linux Torvalds. The same happens with Canonical and Ubuntu. They make a lot of commits that will never go back to Linux Torvalds. And plus, on top of that, we also observe work that is in progress, has not arrived yet in Linux Torvalds. Notice also the number of authors. So in Linux, we only observe 2,883 different authors. We observe 4,575, so almost 50% more in the entire system. So Linux is not only one application, one kernel, but it's really a community of kernels that are being developed on their only one version control system. Let me skip this. And another interesting thing that we observe with this, and it actually talks about the process, is how they arrive at blessed. So the two lines below, the green and the blue, the ones that are horizontal, that's the commits as they appear in the entire ecosystem. So the work is essentially continuous, and it doesn't change from one week to another very much. But the red line, the one that has the spikes, each vertical line, the black one, is the release of a new feature, of a new version of the kernel. So the process of Linux is the following. When a new release of the kernel is made, there is a window of 2 weeks in which new features are accepted. So all those patches that are coming, they arrive at Linux Torvalds. That's actually the big spike. So he accepts commits during 2 weeks. And then after 2 weeks, he only accepts bug fixes. So those little, those very low red lines at the end of each release is just bug fixes. And it's quite interesting because we can now observe patches and divide them into two sets, merge window and fix window. And it's quite fascinating that every single version has almost the same number of commits. It's almost like Linux Torvalds has a metronome, and he counts, OK, I'm done for this release, next one. And the number of bug fixes is also relatively stable in each one of those releases. Now, with respect to the time that I take to arrive, so the time of arrival is the following. So I create my patch, and maybe 3 weeks later, it arrives at Linux Torvalds. That's this time of arrival. So for the merge window, the time of arrival is around, the average is around 30 days. But there have been some in 2012 that took 1,500 days to arrive. So that means that somebody started a feature 3 years before, so 4 years before, and it started to have a small, it started to grow, and then it was sent to Linux Torvalds. So that actually tells you about how independent the work can be in this model. But the bug fixing window, the average is around 7.5 days. So the bugs, they go quickly into the kernel. This is a very quick overview of the repositories. Each one of those dots is a repository. The darker the repository, the less commits it contributes to Linux Torvalds. And so, for example, the ones at the bottom right, those are repositories that have a lot of non-merges. So those are the patches. And, but they don't contribute much to Linux Torvalds. Those are usually distributions. Those are the ones that are built by Samsung, the ones that are built by Android, the ones that are built by Texas Instruments, Canonical, etc., etc., etc. And the lighter ones are the ones that they are being contributed towards Linux Torvalds. So the lighter the repository, the more that the commits there end in the official kernel. And then at the very bottom, because on the left-hand side is merges, so the higher you are, the more integration work you do. And the lower you are, that means you don't care about merges, you're just creating new commits. That's why you see a lot of points at the bottom. Those are people that they are creating, or they are accepting patches from outside via email. This is a graph of how merges flow into Linux Torvalds for 1 day. And so those were 3,800 different commits. And the thickness of the line represents how many commits flow in each one of these channels. All of these ones are repositories owned by different individuals. And the most complex part, the one in the middle above, that's ARM. ARM is one of the areas of the kernel that is the most dynamic these days. And that talks about the use of mobile devices with Android or potentially other operating systems like Tizen. And the one on the right-hand side is the networking system. So there is the wireless one, and then the networking in general. So it's quite interesting to see that the flow that these commits have. And what really happens is that Linus Torvalds trusts each one of these individuals because he cannot review 4,000 commits in one day. He just basically says, I trust that your code is good, and I'm going to accept it. So it's up to each one of those individuals to accept and review the code of the people who submit them to them. So that's actually very fascinating in that respect. What's also interesting is that there is like this hourglass view that you have the contributors to the kernel, you have Linus Torvalds, and then you have what we call the consumers. The consumers, again, are, for example, the distributions. So there's a lot of people, a lot of repositories at the bottom that don't expect the commits to go back. Sometimes they do, very few of them, but a lot of them, they just don't end in Linus Torvalds again. And at the top, you have the people at the kernel.org that work to contribute. So let me quickly now move to GitHub, because what became interesting is that GitHub started to create a service around Git. And I would be very fascinated to know why they thought it was a good idea. But it has proven that it has gone beyond Git. So a few years back, so last year, Gorgeous Gaussius created a system to download all the metadata of every project in GitHub and make that metadata available. So we started to use it and to try to understand how GitHub is being used. And we wrote this paper that is going to appear in a conference this year. And one of the questions we ask is, what is GitHub used for? And this is a response from one of the people we interviewed. He says, I store my presentations in GitHub. I don't need a USB stick anymore. So GitHub is not necessarily only for software development. GitHub is going beyond software development. The Tate Gallery in London, the museum, is storing its metadata for its entire collection in GitHub. Too bad they don't include the photographs of the collection, but at least the metadata is there. So our methodology is combining two things. So one of them is surveys. We're also using the data from GHTorrent, and we sample 400 repositories. So that gives a confidence level of 95%, plus minus 5% with respect to our results. And so we came with 11 potential threats to researchers who are trying to use GitHub. I'll go through some of them because I don't have time for all of them. One of them is uses. So this is, when we sampled the 400 repositories, this is the breakdown of them. So 63% are typical software development. And some of them are experimental, and by experimental we mean like, oh, I want to see how it works. So I commit a file. And then I observe what happens if I commit another file from another place, etc. Storage. It's very widely used today for storage. And some people store their software, which is a combination of both, because they say, so I just want to upload it to GitHub because maybe somebody else can use it, but also I can actually download it from other places. Dot files. So if you are Linux users, you have dot files. A lot of people are putting their dot files in GitHub. That's a very, very common use. I don't know whether you know this or not, but GitHub provides web storage for you for free with your own domain name. It will redirect to your own domain name. And so there's no reason why not to use it. It's free, as long as you only have static pages. And there are repositories that are empty. So people create it, and they never do anything with them. So that's also true. But what's also interesting is that most projects are inactive. And so this graph is the days of activity since creation. So for example, if I create a repository and I only use it for 5 days, and then I never use it again, then it will show under the 5 days category. And there are some repositories that are very active. So around 15% of the repositories have activity, but most of them, after a while, then people don't do anything with them. That actually shows a little bit the idea of using GitHub for storage. 60% of the projects are personal. Nobody else has committed to them. And 95% of them have 3 or less committers. So it's not very social once we're talking about the software development part. Self-contained, and so one interesting thing about GitHub is that it provides you with pull requests, and it also provides you with issues tracking. And but not everybody's happy with them. So people need features outside that. And that, I'll talk a little bit in terms of that. The other thing is that GitHub's information is being used by others to reach conclusions. So for example, this is the open source report card. This is a website that uses mines GitHub. This is my report card. So it says a lot of things that are true, but one of them says that I'm a JavaScript developer. I have never written JavaScript, but because I have my website in GitHub, and it has JavaScript that I copied from Octopress, then it thinks that I commit Java code. So there's a lot of challenges in trying to understand this data. So how are GitHub users using GitHub to collaborate? And I don't have much time, so I'll have to go quickly through this. So this is another study that we're doing with some surveys. And people are using GitHub for many different reasons, all the way from my company is using it, so therefore I have to use it, all the way to I want to contribute to open source. And actually that's the main reason that people go there, because they want to be part of open source. We have three main themes with this. One of them is that they're simple tools. They're very easy to use, and they are centered around the code. The code is the most important part. And the next one is that it's decentralized work. You don't need a lot of management. You know what you have to do. You go and do it, and then at the moment, you make a pull request to have your code. And exposure. So even though you don't have to have the management, you know what the other people are doing because you can go to the repositories. And there's also a lot of peer pressure because everything is visible, and you have to have pull requests authorized. Then you are more conscious about writing good code. It's an interesting side effect of that. And they have very much an open source mentality, and the idea of having independent self-organization in their teams, minimizing coordination and communication, and having ownership of code, and operating in a meritocratic system, even though 27 of the people we interviewed were working for a company using GitHub. And finally, we're also discovering that there's a very interesting aspect of the GitHub ecosystem. And so GitHub is creating an ecosystem of a lot of applications that integrate with GitHub. So code is at the center of them, and the commits are at the center of that. Asana, Campfire, Lighthouse, Jira, Travis, many of them might be used by you already. And this is a matrix of how integrated they are. So of course, the development is almost covered by GitHub, but there are still external tools that help. For example, incremental build systems and continuous integration. And there are others like communication with this. It was never really intended for, where all the tools are actually fitting better. Anyway, so just to conclude, and so I think that Git and GitHub are doing an extremely good job in promoting pull requests and code reviews in general in software development, not only in open source, but also in proprietary software. It may also be because young people are starting to go into companies, and the young people has been already influenced by open source. So it's difficult to separate both. And the thing that we are observing is that there's a lot of push towards independent work, and then once you finish that work, to have code reviews, to have that integrated. Just to finalize, that's my website, and oh, sorry, toolmachine.org, so it should be .org. In case that you're interested in any of the presentations, just email me, and I'll send it to you. Yeah. So any questions?
Hi. In the study of the Linux repositories, do you download just the log or the whole code?
We have every single patch and the metadata since November of 2011. Yeah, so the computer running it has already 3 terabytes of data. Yes.
Wow. And how long does it take to fetch all deltas?
So one of the reasons we do it every 3 hours, because it takes around 2 hours. So we have a little bit of a window. Sometimes it depends on network availability. So sometimes a little bit slower, but it's around 2 hours what it takes for us. And most of the time is the time that it takes for Git to verify what it has locally, and compare against the repository remotely. And that's where most of the expenditure is.
Okay, thanks.
Well, thank you very much.